2 consecutive power outages occurred. The first, the October 1st United States government shutdown, is widely recalled. However, the second blackout is known to very few. On September 1st, a billion-dollar spacecraft locked onto one of the most peculiar visitors our solar system has ever encountered. The pivotal moment arrived on September 3rd, and precisely when history was poised to be made, the cameras went dark. Not for mere hours, but for days. That opportunity is now lost forever. Was it an accident, or was it intentional? What could NASA have witnessed that necessitated such absolute silence? Tonight, we are lifting the veil on this blackout, and what we uncover is not only disquieting, but also serves as evidence for what many of us have suspected about this interstellar visitor. If these revelations have you on edge, just as they have me, please hit the like button and subscribe immediately so you don't miss a single update as this narrative unfolds in real time. Leave a comment indicating where you're watching from, the current time there, and whether you believe we are being presented with the complete truth or merely the version they wish us to perceive. And if you're eager to propel this community forward, please share this video on X, Facebook, Reddit, or even your personal group chats. You are the reason we can continue to pursue stories of this nature. Thank you for your unwavering support. Part 1. The Missing Days. NASA deliberately ceased its data transmissions, not the entirety of its space program, nor the internet, but something very specific transpired during the initial week of September 2025, the full explanation for which eludes us. A spacecraft named Psyche, a mission established to investigate a metallic asteroid millions of miles distant, was slated to photograph an entity that paid our solar system a visit from interstellar space. This entity was an object designated 3I Atlas, and according to NASA's own public schedule, Psyche was anticipated to capture images of this visitor on or around September 3rd or 4th, 2025. However, here lies the strangeness. When researchers sought these images within NASA's public archive, specifically the raw image database where every photograph Psyche captures is purportedly uploaded for global access, they found absolutely nothing. No images from September 1st, no images from September 2nd, no images from September 3rd or 4th, no images from September 5th. The archive had simply fallen silent. Then, on September 8th, the images reappeared. 3 days. A 72-hour void in a spacecraft's publicly accessible data during one of the year's most eagerly awaited astronomical events. And officially, no explanation was provided. The Psyche spacecraft itself is no forgotten probe gathering dust in a remote corner of the solar system. This is a state-of-the-art mission, funded by NASA with hundreds of millions of dollars, equipped with high-resolution imaging cameras capable of rendering metallic surfaces with breathtaking detail. The very purpose for which Psyche was constructed was to approach a metallic asteroid designated 16 Psyche and photograph it with a precision that would rival some of Earth's finest cameras. Therefore, this spacecraft, this pinnacle of technological achievement, was ideally suited to observe 3 Atlas as it traversed our cosmic neighborhood. NASA's own publicly disseminated mission overview explicitly identified 3 Atlas as one of Psyche's intended targets. It was neither a secret nor classified. It was openly announced. And then, at the critical juncture, when the spacecraft was perfectly positioned and ready, when the window of opportunity was open, the images vanished from public view. What precisely is 3 Atlas? It is an interstellar object. This signifies that it did not originate within our solar system. It journeyed from some other point in the galaxy, traversing the vast emptiness of space at extraordinary speeds. And in 2025, it passed sufficiently close to Earth for scientists worldwide to desire its study. We seldom have the chance to examine visitors from the stars. When they arrive, the entire astronomical community mobilizes. Telescopes are directed skyward. Spacecraft adjust their trajectories. Data streams in real time. These are the moments that shape scientific understanding. These are the moments that lead to discoveries. Except this time, for those crucial 3 days, absolutely nothing flowed. Community researchers, astronomers, and space enthusiasts who routinely monitor these archives immediately recognized the gap. They flagged it. They discussed it online. They posed questions. Yet NASA offered no official clarification. Not a word regarding a technical malfunction. Not a statement about delays in data processing. Not even a simple acknowledgement that the gap had occurred. The agency simply allowed the silence to persist. Now, one might suggest that the gap could be attributed to the United States government shutdown scheduled for October 1st, 2025. Perhaps backup data systems failed. Perhaps something about the shutdown impacted the archive. However, this line of reasoning doesn't hold water. The shutdown happened in October, while the gap occurred in September. An event that takes place later cannot explain something that happened previously. The chronological sequence simply does not support this hypothesis. Thus, we are left with a mystery that stems from no external event, no scheduled maintenance window, no known technical failure. It is a gap for which, to our knowledge, no adequate explanation has ever been provided. Consider, for a moment, the implications of this situation. Reflect upon the fact that we live in an era of unprecedented transparency in space science. Every image captured by the James Webb Space Telescope is disseminated. Every photograph from the Mars rovers appears online within hours. Every data point from numerous space agencies flows to public archives almost instantaneously. Yet, in this specific instance, during this particular time frame, with this specific object, the system inexplicably ceased functioning. The question then becomes not simply what transpired, but why. Did Psyche fail to orient itself toward 3 Atlas as planned? Did the camera malfunction at precisely the wrong moment? Did something entirely different occur that we have not yet been informed of? Or, and this is the thought that persistently lingers, were the images captured and subsequently deliberately removed from public access? What motive would an agency have for making such a decision? We do not yet possess the answer. However, we are on the verge of discovering that this gap is not an isolated occurrence. This marks the commencement of a pattern. This is the initial thread in a far more extensive tapestry of silence, delay, and enigma that spans multiple space agencies, multiple missions, and multiple weeks. This is the beginning of what we might term the blackout. And as we meticulously unravel this thread, the entire panorama of NASA's and ESA's activities concerning 3I Atlas data begins to disintegrate in ways that challenge everything we previously understood about transparency in space exploration. Part 2. ESA's 2099 glitch and the April 2026 lockbox. While NASA's Psyche probe was experiencing its data blackout over Earth, something equally peculiar was unfolding on the opposite side of the Atlantic. The European Space Agency, which operates a spacecraft known as the ExoMars Trace Gas Orbiter, or TGO, was also expected to have access to 3I Atlas as the object journeyed through the inner solar system. The ExoMars mission typically makes its data available to the public within months of its collection. Scientists are able to download images, spectra, and raw measurements. The system is designed for openness and for sharing. However, when researchers examined ESA's data archive for 3I Atlas observations, they discovered something that caused them to pause. The release dates for certain datasets were listed as the year 2099. 2099. This is not a minor typo indicating a processing delay of a few weeks or even months. This is a date that positions the data 74 years into the future. It is a timestamp that, for all practical purposes, renders the data inaccessible indefinitely, or at least for a duration so extended that most of us will not live to witness its release. Initially, many researchers presumed this to be a simple metadata error, a software glitch where dates were corrupted or default timestamps were incorrectly populated. Such occurrences are not uncommon in complex information systems. But then, something else occurred. The dates began to change. Not all of them disappeared, but many were updated to a new timestamp, April 3rd, 2026. Suddenly, instead of anticipating a release in the year 2099, researchers were informed that these datasets could be expected on April 3rd, 2026. That is 5 months from the present time. Well, it was 5 months at the time the announcement was made. It is now closer. But this presents a conundrum because April 3rd, 2026 still represents a significant delay. It is months away. It is effectively a lockbox. The disparity between NASA's approach and ESA's is instructive. NASA simply removed the images from public view and remained silent. ESA, at least, acknowledged the existence of the data and indicated it would be released at some future point. However, the very fact that ESA felt compelled to establish a release date so far in the future raises disquieting questions. Why would any space agency deliberately postpone the release of scientific data by 6 months or more? In the normal course of operations, data pertaining to comets, asteroids, and interstellar objects is promptly disseminated to the scientific community. Yet, in this instance, both agencies appear to be operating under divergent protocols. NASA's silence could be interpreted as a technical anomaly. However, ESA's deliberate date setting, the fact that someone within their organization specifically selected April 3rd, 2026 as the release date, suggests a more calculated intention. Examining the history of space missions reveals precedents for extended embargo periods. The Hubble Space Telescope, in its nascent years, had a phase where data was first released to the team that had requested the observations before being made publicly accessible. Some images from Mars rovers have experienced delays due to scientific processing requirements. However, these embargoes typically extend for weeks or months at most. 74 years is in a category entirely its own. 74 years is not a processing delay, it is a decision. It is a deliberate choice to sequester something so thoroughly that it effectively vanishes from public consciousness. The justification offered when ESA eventually addressed the issue was technical in nature, citing a metadata problem, a system glitch. However, the 2099 date opens up an entirely different possibility. What if that was not an error at all? What if someone, somewhere, intentionally set that date as a means of concealing the information in plain sight? What if a placeholder for classified or sensitive data was inadvertently left visible in the archive and subsequently had to be rectified once it was noticed? We cannot ascertain this with certainty, but the timing, the deliberate nature of the action, and the shift from one timestamp to another strongly suggest that individuals were making conscious choices about what the public would and would not be allowed to see. The implications are profound. If both NASA and ESA handled 3i Atlas data differently from their standard procedures, if both agencies appear to be delaying or withholding observations, then we are no longer confronting isolated technical issues. We are observing a pattern. We are witnessing something that both organizations deemed significant enough to warrant special handling. And the critical question then becomes not merely what transpired, but what did they observe that led them to decide to lock the data away? What observation necessitated such a lockbox? What image, spectrum, or dataset compelled both a European and an American agency to abruptly alter their customary protocols for public transparency? The answer to that question may well reside in what the object itself was revealing. Because around the same time these archives were going dark, new images and spectroscopic data concerning 3i Atlas began to emerge. And what those images depicted was something that no comet should ever exhibit. Part 3. The Sunward Jet Confirmed. In August of 2025, new imagery of 3i Atlas became accessible to researchers. These observations were acquired from ground-based telescopes and from space-based instruments. And when scientists scrutinized the photographs, they witnessed something that commanded their immediate attention. There was a discernible jet of material directed toward the sun. Now, anyone with a rudimentary understanding of comets knows that this is contrary to expected behavior. When a comet approaches the sun, the heat causes sublimation. These ices transform into gas and dust, and the radiation pressure from the sun's light propels that material outward, away from the star. This is the reason comets possess tails that stream behind them like wind-blown hair. The tail invariably points away from the sun. This is as fundamental to cometary physics as gravity is to falling objects. Except, 3i Atlas did not appear to adhere to this principle. The spectroscopic data was equally perplexing. Researchers utilizing the Keck Observatory in Hawaii collected light from 3i Atlas and performed an analysis. The results indicated emissions of nickel and cyanide, elements found in some comets, but rarely in this specific combination. The object also displayed what scientists termed an anti-tail, a secondary tail that forms in front of the primary tail, but in this instance, it was pointing in an unusual direction. This behavior deviated from any standard cometary model. It was as if something was actively expelling material toward the sun, rather than the sun's influence pushing material away. Consider the distinction between wind-blowing leaves outward from a tree and a leaf blower deliberately directing air inward. The sun is supposed to function as the leaf blower. It is supposed to be the force driving the expulsion. However, 3i Atlas seemed to possess its own intrinsic mechanism. When this observation of a sunward jet is considered alongside earlier data from the James Webb Space Telescope, which indicated that 3i Atlas's atmosphere was predominantly composed of carbon dioxide, the scenario becomes even more enigmatic. A coma rich in carbon dioxide suggests that the object formed in proximity to what astronomers refer to as the carbon dioxide ice line, a region within a protoplanetary disk where carbon dioxide would freeze. This chemical composition is unusual for a comet purportedly originating from the Oort cloud, the vast reservoir of icy bodies encircling the solar system. It is an atypical chemistry for something arriving from interstellar space. It is the kind of chemistry that prompts inquiries into the object's true origin and the forces that have shaped its behavior. The sunward jet, in particular, occupied the thoughts of all who studied the data. A jet directed toward the sun is not easily explained by natural cometary physics. But imagine, for a moment, a spacecraft. Envision a vessel traversing space that required a method for dissipating excess heat or maintaining its orientation. A craft pointed toward the stars might vent material towards the sun as a means of recharging, absorbing radiation, or preserving stability. The directionality in such scenarios is crucial. It is not random, but purposeful. The timing of this observational release was also noteworthy. The August image emerged just as Psyche was preparing to observe 3I Atlas in September. The spectroscopic anomalies had already been recognized by the scientific community. It was widely understood that this object was exhibiting aberrant behavior. It was known to display characteristics that did not align with established models. And then, precisely when a spacecraft equipped with some of the most sophisticated imaging technology ever developed by humanity was poised to conduct an even more detailed examination, the data stream from that spacecraft ceased. The archive went dark. 3 days of silence. The August observations had heightened everyone's anticipation. They had revealed something fundamentally peculiar about this object, and at the very moment when the logical next step would have been to follow up with higher resolution imagery from Psyche, that information vanished. The sunward jet is not merely an anomaly. It is a signature. It is the type of behavior that prompts scientists to question what is occurring beneath the surface. When you observe a jet pointing in the incorrect direction, when you detect compositions that defy expectations, when you witness an anti-tail that challenges conventional explanations, you begin to contemplate whether you are observing a natural phenomenon or something entirely different. You start to ponder if this object is behaving in accordance with the physical laws as we comprehend them, or if it is acting according to some alternative logic, some other purpose. And if that is what Psyche captured, if that is what the images revealed, then it becomes evident why those images might have been deliberately withheld, as they would have raised questions that the agencies might not be prepared to answer. They would have necessitated a confrontation with something the scientific community was not yet ready to discuss. And thus, the silence deepened. Part 4. The silence from Psyche. Following September 8th, when Psyche's archive resumed its regular flow of images, the spacecraft continued to capture photographs as it always had. However, if you meticulously examined every image Psyche acquired, if you perused every blog post NASA published concerning the mission, if you scoured the social media accounts of project scientists and engineers, you would find not a single subsequent mention of 3I Atlas. There was no discussion regarding what Psyche had observed during its approach window. There was no release of detailed imagery. There was no scientific paper submitted for peer review describing the observations. There was simply nothing. The silence was not confined to the archive. It permeated every aspect. This absence is particularly striking, considering that, mere weeks before September, scientists associated with the Psyche mission had publicly expressed considerable enthusiasm regarding the prospect of observing 3I Atlas. There were interviews, explanations detailing the spacecraft's capabilities, how its cameras could capture intricate detail, and the potential scientific discoveries that might arise if the celestial alignment proved favorable. The opportunity had been prominently marked on calendars. The scientific community had been duly prepared. And then, after the observation window had passed, all of that vanished. The scientists fell silent. The mission website made no reference to it. It was as if the entire observational campaign had been expunged from the official record. Several plausible explanations could account for this profound silence. The most straightforward explanation involves a technical malfunction. Perhaps Psyche's cameras were directed elsewhere when 3I Atlas was at its optimal viewing angle. Perhaps there was a loss of telemetry. Perhaps the spacecraft encountered some form of malfunction that prevented it from capturing the necessary data. These occurrences are not uncommon in space operations, as spacecraft are complex machines operating within an unforgiving environment. However, if such a scenario were the case, NASA would typically issue a statement to clarify the situation. They might state something to the effect of, "Our spacecraft was aimed at this target, but experienced a brief communications anomaly," or "Psyche successfully imaged the object, but technical issues prevented the download of the complete dataset." Such statements are routine and are a standard part of normal mission operations. Yet, in this instance, no statement was forthcoming. Another possibility is that the acquired data necessitated internal review. Perhaps Psyche captured something unexpected, something that the scientists wished to examine more thoroughly before sharing it with the public. Perhaps the images revealed anomalies that triggered a requirement for calibration review or peer assessment. This, too, is not without precedent in the history of space missions. The Galileo spacecraft, in the 1990s, captured images of Jupiter's moons that revealed unforeseen geological features. Researchers spent months analyzing and verifying these findings before publication. However, even in those instances, agencies issued statements indicating that analysis was in progress. They prepared the scientific community for a delayed release. They did not simply retreat into silence. The third possibility is considerably more disquieting. It pertains to the potential for classification. If Psyche obtained images revealing unexpected structural characteristics or unusual properties of 3I Atlas, images that suggested the object might be something other than a natural comet, then those images could have been deemed sensitive from a national security standpoint. They might have been placed under classification protocols. This also has historical precedent in space observation. Early reconnaissance satellites returned images that remained classified for decades. Even some of the recordings from the Apollo missions were kept from public view until scientists actively campaigned for their release. If a photograph suggested that an object in space might not be natural but artificially made, it would immediately result in a higher classification level. The consequences of such a discovery would be truly astounding. The repercussions would be immense, and any decision to conceal such an image would originate from authorities far beyond the control room of any individual mission. This prolonged silence has created a significant deficit in our understanding, precisely when we should have had the clearest picture. We have spectroscopic data from August showing an object with unusual characteristics. We have a spacecraft positioned to capture detailed imagery. We have a scheduled period for observation, and then nothing. The void is overwhelming. It's a silence that speaks volumes. It's the absence of information functioning as information in itself. Because in this modern age of extreme openness in space exploration, such silence doesn't occur by chance. It happens because someone intentionally decided it should. Someone made the deliberate choice not to share something the world was eagerly anticipating. And that decision, in itself, is perhaps the most crucial piece of evidence of all. It tells us that an event occurred that someone wished to keep hidden from us. Part 5. The Gap in the Timeline. Let us compile a comprehensive timeline of events from all the space agencies involved. Let us arrange them chronologically and observe the pattern that emerges. In August of 2025, new spectroscopic observations of the object designated 3I Atlas became accessible to the scientific community. The KEK Observatory in Hawaii captured light emanating from the object, revealing emissions of nickel and cyanide. These elemental compositions are unusual. The object's behavior does not align with established models of comet physics. Scientists began to analyze and discuss their findings. Preliminary reports and online publications started to circulate. The astronomical community was abuzz with questions regarding this visitor from another star system. The James Webb Space Telescope also provided data indicating an atmosphere predominantly composed of carbon dioxide, further intensifying the enigma. Towards the end of August of 2025, a high-resolution image of 3I Atlas was obtained. This image clearly depicted a stream of material directed towards the Sun, a phenomenon that contradicts our expectations for cometary physics. The sunward jet now represents tangible visual evidence. It is no longer just a spectral analysis or a measurement. It is a photograph. It is something that can be directly observed. And every member of the astronomical community witnessed it. Everyone discussed it. Everyone was preparing for the subsequent opportunity to gather more data. Then we arrive at the period of September 1st through 5th. This marks a blackout window for NASA's Psyche spacecraft. No images from the spacecraft were made available in the public archive during these 5 days. This window encompasses the scheduled observation dates for 3I Atlas on September 3rd and 4th. Psyche, equipped with the capability to photograph metallic surfaces with exceptional precision, captured nothing that the public could access. On September 8th, the archive was updated. Images reappeared, but none of them depicted 3I Atlas. To date, no images of the object have been found in any public database, as far as anyone has been able to ascertain. October 1st, 2025, saw the commencement of a United States government shutdown, but this event cannot account for the absence of data in September. A future occurrence cannot retroactively cause a past event. The shutdown serves as a misleading distraction in this timeline, a potential explanation that ultimately proves invalid. October 3rd through 7th witnessed a significant astronomical event. NASA's ExoMars Trace Gas Orbiter passed closest to 3I Atlas as the object approached Mars. This spacecraft possesses instruments capable of collecting detailed data. Researchers from the European Space Agency and international collaborators should have been preparing to analyze these observations. They should have been, because the data from this close approach has yet to appear in any public repository. The European Space Agency stated that the information would be made available on April 3rd, 2026. That is months away. It is essentially locked away. October 25th and 26th brought another deadline. NASA's Europa Clipper mission had scheduled observation windows for 3I Atlas in late October. While this spacecraft is en route to Jupiter's moon Europa, it is equipped with high-resolution imaging technology that could photograph an interstellar visitor if properly directed. Will we see those observations? Will the data be uploaded to the archive, or will October bring another period of silence? April 3rd, 2026, is the currently designated date for the European Space Agency to release the data concerning 3I Atlas. This date is marked on calendars. It represents a commitment. However, as we examine this timeline, observing how the pattern of missing data and deliberate delays accumulates, we must question whether that date will be honored. We must inquire whether the information will actually be disseminated, or if we will encounter further postponements, more restricted access, and more classified data sets. What emerges from this timeline is not a series of isolated occurrences. It is a confluence of withheld observations, postponed releases, inexplicable omissions, and secured databases. We observe both American and European agencies treating the same object in a manner inconsistent with their usual procedures. We note predetermined dates for data release that appear intentionally set far into the future. We have a spacecraft with extraordinary capabilities falling silent during its most critical observation period. We have data releases scheduled months in advance, when all other scientific findings are typically made public within weeks. This is not random. This is not a coincidence. This is a pattern. And patterns exist for a reason. Patterns suggest deliberate action. They suggest coordinated efforts. They suggest that multiple organizations have independently, or perhaps in concert with each other, decided that certain information pertaining to 3I Atlas must be withheld from public view, at least for the present. This leads us to ponder what could be so significant, so sensitive, so extraordinary that it would compel two major space agencies to fundamentally alter their standard protocols for transparency and data sharing. The answer may lie in the actual nature of the object itself. Part 6. The Lost Windows, Martian Assets. When 3I Atlas passed in close proximity to Mars in early October, it was not solely observed by the ExoMars Trace Gas Orbiter. Several other spacecraft were in Martian orbit, their cameras pointed towards the sky. The Mars Reconnaissance Orbiter, equipped with a camera named HiRISE, one of the most sophisticated imaging systems ever deployed in space, had the opportunity to observe this interstellar visitor. From its orbit around Mars, HiRISE is capable of resolving objects with a pixel size of approximately 30 centimeters. It can capture details that would be astonishing. It can photograph Martian dust storms with such precision that individual wind patterns are revealed. It can detect objects the size of a car from thousands of kilometers away. Given the appropriate viewing angle, HiRISE could have captured unprecedented detail of 3I Atlas. It could have photographed the object's nucleus. It could have revealed structural features. It could have indicated whether the object possesses a simple, rounded form like a natural comet, or if it exhibits something more intricate, more geometric, more artificial in appearance. But where are those images? Have you encountered any high-resolution photographs of 3I Atlas taken by HiRISE? Have they been released to the public? Have they appeared in any scientific database? As of this moment, the answer is no. The images have not surfaced. The data has not been transmitted to the researchers who requested it. If HiRISE did capture observations, those observations have been kept from public access. Much like the data from Psyche, much like the complete data set from ExoMars, much like the high-resolution imagery we would expect from such a camera system, the history of the Mars Reconnaissance Orbiter and HiRISE is one of transparency. The camera has been transmitting images to Earth for nearly 2 decades. Photographs of Martian surface features are regularly released. The camera has also captured imagery of other celestial bodies within our solar system. When Mars's moons, Phobos and Deimos, pass in front of the camera, we see those images. When comets traverse the Martian system, we have seen photographs. The standard procedure is release. The norm is to share. Yet, concerning 3I Atlas, when the object approached Mars, when HiRISE had the ideal opportunity to capture details previously unseen, the data simply did not follow the customary path. What could be the reason for this? One plausible explanation is technical. Perhaps the camera was scheduled for observations of the Martian surface during that specific period. Perhaps the mission's priority of pointing meant that other targets were deemed more significant. Perhaps there were delays in processing and transmitting the data. These are all conceivable reasons. They are all factors that could legitimately postpone the public release of an observation. However, none of these necessitate the complete absence of the data from the archive. None of them require absolute silence. Typically, when there is a processing delay, the data portal indicates that it is undergoing processing. There is a status update. There is information regarding the potential availability of the data. But consider another possibility. What if HiRISE did indeed observe 3I Atlas? What if it captured high-resolution images that revealed something unexpected? What if the camera showed structural features on the object that surprised the researchers? What if the data suggested that 3I Atlas was not merely a comet, but something else entirely? Something possessing characteristics that demanded further investigation and internal review before any public disclosure. In such a scenario, the data would be withheld. It would be analyzed meticulously. It would undergo scrutiny at multiple levels, and it might be classified, at least temporarily, until decisions could be made regarding what to disclose to the public and how to present it. The absence of high-rise imagery, coupled with the absence of Psyche imagery and the delayed ExoMars data, paints a picture of systematic data withholding across multiple instruments and agencies. We are no longer discussing a single spacecraft going offline. We are discussing a deliberate pattern where every significant opportunity for high-resolution observation of 3I Atlas has resulted in either missing data or delayed data. This is not by chance. This is a decision made at a level above individual mission control centers. Consider what a high-resolution image would reveal that a spectrum cannot. A spectrum provides information about composition, about the elements present in the object's atmosphere. It tells us what exists there. But an image reveals shape. It reveals structure. It indicates whether the object possesses natural, rounded features, or if it has edges, angles, geometric forms. It tells us whether we are observing a natural body shaped by gravitational forces and a history of collisions, or if we are looking at something manufactured, something constructed, something designed. That is the information that would be most perilous to release, because that is the information that would necessitate a dialogue that the agencies might not be prepared to engage in. And so, the images are kept back. The high-resolution views remain secured, and the mystery deepens. Part 7. Plasma propulsion or shield. What if 3I Atlas is not a comet at all, but a machine? What if it is a type of probe, a vessel engineered for interstellar travel, and what we have been observing in its behavior are not natural physical phenomena, but the signatures of active propulsion or operational systems? This idea might sound like science fiction, but let us follow the evidence and see where it leads. Researchers within the community who have closely analyzed the available data have described a peculiar halo surrounding 3I Atlas. They refer to it as being Space Invader shaped, a nod to the pixelated alien from the classic video game. This halo is visible in certain light wavelengths. It envelops the object. It is not the natural cloud of dust and gas that one would expect from a comet. It possesses structure. It has a definable shape. Its edges appear almost deliberately geometric. Is this the consequence of a natural interaction between the object and the solar wind? The stream of charged particles emanating from the sun. That is the prevailing explanation. Solar wind pressure on dust and charged particles would indeed create a halo. Natural plasma distortion could result in apparent structural irregularities. These explanations are plausible within the framework of conventional physics. However, consider an alternative perspective. What if the halo is not a distortion, but an emission? What if 3I Atlas is actively generating a plasma field? What if the object is employing electromagnetic shielding or expelling ionized material as a byproduct of an active system? A spacecraft utilizing plasma propulsion, maintaining a magnetic shield, or dissipating excess heat through ionized gas would produce precisely this kind of signature. The direction of the observed jets, the composition, and the structure of the halo could all align with a model where 3I Atlas is not a passive comet shaped by external forces, but rather an active machine maintaining its own protective environment around itself. The parallel to another interstellar visitor is difficult to ignore. In 2017, An object named Oumuamua entered our solar system and astonished astronomers. It exhibited non-gravitational acceleration, meaning it was increasing its speed in ways that could not be attributed to gravity alone. It also possessed an unusual shape, resembling a cigar or a flat rectangle. The scientific community grappled with explanations. Some proposed natural mechanisms. Others suggested it might be a solar sail, a spacecraft design that harnesses light pressure for acceleration. The discussions were intense and not always amicable. However, the possibility had been raised. The notion that an interstellar object might be something other than a natural comet had been openly discussed. Now we have 3I Atlas with its sunward jet, its unusual composition, its geometric halo, and its anomalous acceleration. And the situation is even more intriguing because we have actual photographic and spectroscopic evidence, not just indirect indications. We possess data that shows the object behaving in ways that natural comets do not. The mainstream astronomical community continues to advocate for natural explanations. They point to carbon dioxide ice lines and unusual nuclear compositions. They cite instances of bizarre cometary behavior observed within our own solar system. They maintain that we should not resort to extraordinary explanations when ordinary ones may suffice. This is sound scientific practice. It is cautious and appropriate. But what if the ordinary explanations are inadequate? What if the data genuinely does not conform to natural models? What if 3I Atlas is anomalous in ways that compel us to at least consider the possibility that we are observing something constructed? Imagine a solar sail probe, a vessel designed for interstellar travel, utilizing radiation pressure as its propulsion source. Such a device would orient itself towards the sun. It would harness solar energy. It would need to adjust its orientation to maintain its course. The jets we observe, the halo effect, the asymmetry in the object's behavior, all of it could be explained by a spacecraft maintaining its position and stability as it approached the sun for a close pass, using our star as both a power source and a navigational reference. This is speculative, certainly, and goes beyond the current scientific consensus, but it is consistent with the observations. It is not disproven by the data. It simply requires a different set of assumptions about the object's nature. And this brings us back to the silence. If researchers within government space agencies had even contemplated the possibility that 3I Atlas might be artificial, might be a probe, might be constructed rather than natural, would they not immediately classify all the data? Would they not involve senior officials? Would they not initiate internal security reviews? Would they not delay releasing information until they had fully comprehended what they were looking at and determined how to present it to the public without causing alarm or an international incident? The silence and the withheld data would make perfect sense if that were the scenario. They would be precisely what we should expect if someone had closely examined 3I Atlas and begun to suspect it was something we had never encountered before. Part 8. The Industrial Alloy Mystery. The spectroscopic data obtained from observatories studying 3I Atlas presents a conundrum that does not fit neatly into our established understanding of cometary composition. Astronomers detected nickel in the outgassing from this object, which in itself is not entirely surprising. However, this is where the anomaly becomes pronounced. They found nickel without any measurable iron in the same analyses. This is unusual. In fact, it is profoundly unusual. On Earth and throughout our known solar system, nickel and iron are consistently found together. They are companion elements in meteorites, in asteroids, and in the cores of rocky bodies that formed alongside our planet. The ratio between them provides insights into the history of planetary formation. Yet, 3I Atlas appears to have either rewritten that history or refused to adhere to the expected narrative. Consider the metallurgical context for a moment. Here on Earth, we have developed methods to separate nickel from iron through industrial processes, such as the nickel-carbonyl refining technique. When humanity requires pure nickel metal, distinct from iron, we have devised ways to achieve that separation. Furthermore, we have engineered high-nickel alloys, materials with designations like Inconel, which combine nickel with other elements to create substances capable of withstanding extreme conditions. These alloys are intentionally designed. They are crafted for specific purposes: durability in harsh environments, resistance to corrosion, and the ability to function near intense heat sources like the sun itself. No natural process that we currently understand routinely produces such refined metallurgical compositions in space. Yet, here in the outgassing from an object approaching our star, we find this signature. The JWST satellite, which has been observing 3I Atlas with its remarkable infrared sensitivity, has provided another piece of the puzzle. The coma surrounding this object is dominated by carbon dioxide ice. This is significant because it suggests the object originated under conditions vastly different from those of typical solar system comets. Most comets forming in the outer regions of planetary systems carry signatures of water ice and volatile compounds associated with the familiar cold zones we understand. However, a carbon dioxide-rich nucleus points to formation near what astronomers refer to as the carbon dioxide ice line, a region where conditions favor this specific chemistry. The question becomes unavoidable. What object follows such an unusual compositional recipe? We must inject a necessary note of scientific caution here, because the temptation towards extraordinary conclusions must be balanced against the reality that nature sometimes produces peculiar ratios without requiring exotic explanations. A single anomalous reading, even if carefully obtained, does not automatically confirm the involvement of technology or design. Natural processes can be more peculiar than we anticipate. Solar heating, unique formation histories, or even chance combinations of stellar dust and volatile compounds might account for these signatures. The scientific method demands that we remain skeptical, even when the data appears to lead to an extraordinary conclusion. Yet, consider an analogy that might clarify why this is important. Imagine you are sifting through a collection of meteorites, fragments that have fallen from space, all exhibiting the expected mineral signatures of natural formation. You then discover a fragment of metal exhibiting the distinct attributes of spacecraft-grade alloy. This specific high-nickel composite is known to form exclusively under manufactured conditions. Consequently, your line of inquiry would shift dramatically. You would urgently seek to ascertain its presence, its origin, and whether it genuinely belongs amidst the naturally occurring rock formations surrounding it. While the discovery itself doesn't definitively prove artificiality, it compels a significantly intensified investigation. Should the composition of 3I Atlas genuinely diverge from established natural materials, both the Psyche spacecraft and other astronomical observatories would logically interpret the collected data with a heightened level of scrutiny. Specialized review protocols might be initiated. Scientific committees could be convened. The object might even be assigned a classification that sets it apart from routine observational comments. This is not speculative conjecture. It is the protocol of established institutions. When an anomaly arises that defies conventional categorization, entities designed to uphold standards naturally increase their vigilance. A critical blind spot emerges here. If the object is indeed of an unusual composition, then the silence surrounding Psyche's missing telemetry window gains substantial significance. It implies not an accidental oversight, but a deliberate act of control. This brings us to a pivotal question that will guide our further exploration. Could the data be intentionally withheld because the contents of 3i Atlas are simply too unexpected for processing through standard channels? Part 9. Coordinated suppression. The notion that multiple space agencies might collaborate to conceal or delay information concerning 3i Atlas initially sounds like the narrative of paranoia, conjuring images of clandestine meetings, covert committees, and hushed directives exchanged in secluded offices. However, upon disengaging from superficial reactions and patiently examining the timeline of events, a more subtle yet profoundly disquieting pattern begins to emerge. The recurring patterns in the communication of intelligence, whether human or artificial, and the contextual circumstances surrounding this object are becoming increasingly difficult to dismiss as mere coincidence. NASA and the European Space Agency function under disparate governmental structures, distinct funding mechanisms, and varied institutional cultures. One answers to Washington, while the other is accountable to a confederation of European nations, which frequently experience disagreements on budget allocations, let alone policy decisions. In theory, these two organizations should exhibit differences in their methods and responses. Yet, as we traverse the timeline of 3i Atlas, their actions demonstrate convergence, not through overt collusion, but through a synchronized choreography of hesitation, suppression, and delay. It is as if separate orchestras, performing different pieces in distinct venues, simultaneously struck the identical note. History serves as our guide in this matter, and historical accounts rarely lend credence to the idea that governments and agencies fully disclose all information. During the Galileo mission in the 1990s, the spacecraft transmitted images of Jupiter's moons that were so extraordinary they challenged existing assumptions about those frigid celestial bodies. Some of this data experienced delays, underwent careful filtering, and was released incrementally. The Apollo program, celebrated as humanity's monumental stride, generated hours of audio and telemetry that remained classified for decades before becoming publicly accessible. In the era of the Cold War, entire categories of reconnaissance satellites operated in orbit, capturing imagery of Earth with technology so advanced it dwarfed the capabilities of civilian astronomy. The public remained unaware of these machines' existence until subsequent leaks and declassifications decades later. The established pattern is clear. Certain classifications of data are subjected to special handling, not due to a lack of scientific significance, but precisely because they possess an overwhelming amount of it. The established frameworks that explain this behavior are neither mysterious nor unconventional. The primary framework is national security. If 3i Atlas proves to be more than a mere comet, if it has implications for planetary defense, the sovereignty of space, or even technological parity with an unknown intelligence, then immediate disclosure would not be the default course of action. Instead, it would trigger protocols, layers of review, and interagency deliberations. Planetary protection represents a second relevant framework. Scientists bear a responsibility to assess potential hazards, whether biological or material. If an object suggests even a faint possibility of risk, agencies tend to err on the side of caution and silence until risk assessments are completed. A third framework involves international collaboration. When multiple nations are investigating the same phenomenon, embargoes and controlled releases are implemented to prevent widespread confusion. The objective is not secrecy, but consistency, although to the public, the outcome often appears indistinguishable from suppression. Finally, there are considerations related to commercial interests and mission priorities. When substantial investments, such as those made in spacecraft like Psyche or ExoMars, are involved, the teams responsible for developing the instruments often expect a period of exclusive access to their data. This period can extend from months to years, creating natural delays that coincide with critical moments of discovery. All of these factors could potentially be attributed to innocent procedural reasons. Nevertheless, the uncomfortable reality is that NASA has historically been exceptionally transparent with data pertaining to comets. The Hubble Space Telescope has captured numerous images of comets, and these were incorporated into public archives with only minor delays. The James Webb Space Telescope, despite its remarkable sensitivity, has made its discoveries available to the public within weeks. The Rosetta probe, while orbiting Comet 67P, transmitted images in near real time, almost as if inviting global participation in the discovery process. In essence, comets have not typically been subjects of secrecy. They have been shared, analyzed, published, and displayed. Therefore, one must ask, why does 3I Atlas deviate from this established pattern? Why is this particular visitor treated with a level of discretion that results in silences where a deluge of imagery would be expected? The chronological sequence of events serves as our evidence, and the coincidences within it verge on being orchestrated. In early September, Psyche experiences its data blackout, a period where unexplained gaps appear in its telemetry stream. Days later, the European Space Agency's ExoMars data release encounters an unusual placeholder date of 2099. This error serves as a justification for a comprehensive delay, pushing the release of information until April of 2026. At the precise moment this interstellar visitor enters its most critical phase, the data channels that could illuminate its behavior become obscured. Meanwhile, on Mars, the high-resolution imaging science experiment, HiRISE instrument, capable of capturing exceptionally sharp images, remains on standby for data release. There is no official denial, no explanation, only an unnerving silence. A single agency experiencing such issues might be dismissed as coincidence. Two agencies exhibiting similar problems could be attributed to bureaucratic inertia. However, three or more agencies exhibiting aligned hesitations begin to suggest a deliberate design. Let us pause at this juncture. It is crucial to acknowledge the limitations of this analysis. There is no definitive proof, no leaked directive from a NASA official announcing that 3I Atlas has been classified. No whistleblower from the European Southern Observatory has come forward admitting to instructions to embargo the images. What we possess instead is a collection of suspicious temporal alignments, a pattern that echoes across different agencies and missions. Skeptics will contend that mere bureaucracy accounts for these delays, arguing that accidents and glitches are commonplace. Their argument is not without merit. However, those who have extensively studied institutional behavior recognize that accidental occurrences tend to cluster most predictably around moments of unease, when a system encounters something it cannot readily comprehend. This is precisely why suspicion persists. What initially appears as disarray begins to resemble a coordinated sequence of events when mapped over time. Why has what should be a profusion of comet imagery instead become a scarcity? Such scarcities are rarely accidental within a system designed for continuous output. The fundamental question then becomes, what circumstances would necessitate such secrecy? If 3I Atlas were a standard comet, there would be no justification for it. If it were a simple celestial body, there would be no reason for hesitation. The very existence of suppression implies that the object transcends ordinary classifications, that it has triggered protocols typically reserved for anomalies. Once this conclusion is reached, the implications extend into unsettling territory. Are we observing an interstellar probe, a machine designed to harness solar energy, or a remnant of a civilization that predates our species' capacity for written language? Or perhaps something even more extraordinary, something that blurs the distinction between the natural and the artificial? The honest answer is that we do not yet know. However, the silences, the delays, and the carefully staggered releases speak volumes, conveying a message as potent as any official announcement. They indicate that something about 3I Atlas has unsettled the institutions that govern our access to space. They suggest that the conventional narrative of just another comet is insufficient to explain the remarkable choreography of suppression we have witnessed. Consequently, we arrive at a synthesizing hypothesis that propels this investigation forward. What if 3I Atlas is not merely a comet? What if its anomalies, the sunward jet, the nickel-rich composition, the suspicious observational gaps, are not errors or outliers, but rather indicators of something entirely different, something that space agencies are not yet prepared to reveal, but are unwilling to disregard? If this is the case, then the silence is not an absence of information, but a signal. It is the sound that institutions make when they have encountered something profound and have concluded that the public is not yet ready to perceive it. Part 10. The Sun Machine Hypothesis. All the disparate threads now converge into a single, haunting question. This is the question that has lingered unaddressed in the periphery of every anomaly, every missing data set, every hesitant utterance from the institutions entrusted with conveying truth. What if 3I Atlas is not simply a comet, not merely an inert fragment of frozen debris drifting aimlessly through the cosmos, but rather something far more deliberate? What if it is a probe, a machine, a construct of intelligence actively harvesting our star's energy for its own propulsion or operational needs? At first impression, such a proposition may appear audacious, even imprudent. It encroaches upon the realm of science fiction, evoking images of extraterrestrial technology in a field where scientists typically favor the assurance of naturalistic explanations. Yet, boldness is not synonymous with error. The justification for giving this hypothesis serious consideration lies not in its proven veracity, but in its capacity to unify disparate anomalies into a coherent pattern that conventional frameworks struggle to accommodate. Like a key fitting a lock, the hypothesis of an artificial probe offers a more comprehensive explanation with fewer assumptions, whereas naturalistic explanations must become increasingly strained to account for the widening discrepancies. The starting point is straightforward, undeniable, and captured in a single image: the sunward jet. The photograph, dated October 16th and released with calculated precision, elicited mounting disquiet. It depicts a stream of material erupting not away from the sun, as dictated by physics, but rather towards it. For a comet, this phenomenon represents a fundamental contradiction. The thermodynamics of sublimation dictate that when solar radiation heats the volatile ices within a comet's crust, gases are expelled outward, expanding in the vacuum and propelled away from the star by momentum. Cometary tails invariably point outward, a celestial ballet orchestrated by heat, pressure, and radiation. However, in the case of 3I Atlas, we observe a defiance of these principles, a plume directed sunward, a comet that appears to move against the prevailing solar wind. Interpreted as a natural occurrence, it is perplexing. Viewed as a byproduct of propulsion, it becomes comprehensible. Imagine thrusters expelling material in controlled bursts. Envision a spacecraft utilizing exhaust or energy ejection to adjust its trajectory, correcting its course as it approaches perihelion. Suddenly, the physical laws align. The anomaly transforms into a maneuver. The inexplicable becomes coherent. When this observation is juxtaposed with other peculiar findings, the overall picture becomes sharper. The nickel-rich composition, revealed through spectral analysis, raises significant questions. In natural occurrences, nickel is often found in conjunction with iron, forged in the violent processes within stars. To isolate nickel requires considerable energy, a metallurgic process akin to industrial refinement. Why would a random interstellar body exhibit such a composition unless it had undergone processing? Unless, perhaps, it is not a fragment of stellar collapse, but rather a product of engineering. Furthermore, the detection of carbon dioxide in quantities inconsistent with typical cometary models is noteworthy. While chemistry can indeed produce surprising results, the concentration and ratios observed here suggest intentional manipulation rather than simple inheritance from a random interstellar dust cloud. The Psyche probe, strategically positioned at the optimal moment and vantage point to capture clarifying imagery, experienced a peculiar blackout, a loss of data stream that remains officially unexplained, but is conspicuously timed. Is this a coincidence or a deliberate arrangement? Individually, none of these phenomena definitively prove artificial origin. However, collectively, they resonate. Each element transitions from being a mere peculiarity to a puzzle piece within a larger framework, converging on an outline that only becomes discernible when we entertain the possibility of technology. The analogy to our own technological endeavors is unavoidable. Consider the concept of solar sails, spacecraft propelled not by chemical propellants, but by the pressure of photons emanating from stars. This is no longer a speculative concept. NASA has funded research in this area. Prototypes have been successfully launched, and entire research communities are dedicated to exploring the mechanics of such propulsion. If humanity, still in its nascent stages of cosmic exploration, has already embraced this concept, why should we assume it impossible for another intelligence, ancient, more advanced, and far more patient, to employ similar methods on interstellar scales? Now, let us extend this analogy further. Physicists have long speculated about Dyson spheres, vast arrays of structures designed to capture stellar energy, orbiting stars like colossal industrial halos. What if 3I Atlas represents a fragment of such an infrastructure? A probe, a scout, a component designed for observation, measurement, or evaluation. Or perhaps it serves a simpler, almost elementary function: a vessel expelling excess heat, a machine discarding waste materials sunward to maintain thermal equilibrium. The plume we perceive as impossible might simply be routine maintenance for a craft operating far beyond our current comprehension. Skeptics, of course, offer counter-arguments, and their voices merit consideration. Astronomers with decades of experience remind us that comets are inherently unpredictable. Outgassing can be chaotic, and jets can erupt in unusual orientations. Rotational dynamics can contort plumes in unexpected ways. To infer technology from anomaly, they argue, risks overreach. It risks engaging in pattern recognition where randomness is sufficient. Scientific publications emphasize the importance of patience and warn against allowing our desire for meaning to distort data into narratives of alien probes. This caution is prudent. Skepticism serves to safeguard science from devolving into fantasy. However, when wielded too rigidly, skepticism can become its own form of dogma, blinding us as effectively as credulity. To dismiss anomalies by perpetually citing natural eccentricities is no less ideological than to immediately conclude the presence of technology. The imperative lies in achieving a balance. We must respect the expertise of astronomers while also remembering that history's greatest scientific advancements have occurred when individuals dared to declare, "Our current framework no longer explains what we are observing." Copernicus reimagined the celestial order not out of a desire for audacity, but because the Ptolemaic system had become inadequate. Darwin posited the theory of evolution not for the sake of controversy, but because accumulating anomalies in natural history necessitated a new explanation. Scientific progress is contingent upon our willingness to acknowledge the limitations of established categories. And now, with 3i Atlas, we may stand at a similar precipice. 3 distinct possibilities crystallize. Firstly, 3i Atlas is a natural celestial body, an exceptionally peculiar comet whose oddities, however strained our explanations may become, still fall within the established boundaries of physics. Secondly, it is a probe, a machine, an artifact of intelligence, either seeded by our own civilization in the distant past or an emissary from another. Thirdly, it is something liminal, an entity that straddles the boundary between these classifications, a hybrid system where natural processes and intentional technological design blur in ways we cannot yet fully grasp. If it is natural, we gain a deeper sense of humility, expanding the scope of cometary science to encompass phenomena we had not previously anticipated. If it is artificial, the implications are profound. It would signify that technology capable of interstellar travel exists and has already made contact with us. It would mean that the apparent silence of the cosmos is not silence at all, but rather that we have been too unprepared, too unimaginative, and too institutionally cautious to recognize the signals when they have arrived. The final possibility, the hybrid, may prove to be the most unsettling. Advanced technology could be indistinguishable from geological formations. Machines operating on principles we barely comprehend might mimic comets or asteroids so closely that our existing classification systems become obsolete. 3i Atlas might not be an intruder disguised as a comet, but rather a comet that has been adapted, engineered, or co-opted for a specific purpose. The natural body and the artificial system might coexist, rendering our distinctions meaningless. And here, the human element intrudes. If such possibilities exist, how would our institutions respond? Would they announce the discovery, rewriting history in an instant? Or would they retreat into silence, fearing societal disruption, widespread upheaval, or the loss of control over the narrative? We have already observed the preliminary signs, the data blackout experienced by Psyche, the reticence from agencies that should be most vocal. The precedent suggests that extraordinary data, rather than being widely publicized, is instead quarantined. It is locked away behind the closed doors of committees and bureaucratic processes, while the public is presented with the most benign narrative of icy debris and errant comets. This is why the artificial probe hypothesis must be seriously considered, even if it evokes discomfort. Not out of certainty, but because ignoring it risks willful blindness, because anomalies warrant explanations that are fitting, and because the silence emanating from institutions is, in itself, a significant signal. 3i Atlas challenges us to confront not only the cosmos, but also ourselves, our willingness to perceive what is before us and to demand transparency from the structures that claim to uphold truth. What if, in the jet streaming sunward, we are witnessing a deliberate maneuver? What if, in the metallic composition, we are observing the traces of design? What if, in the silence surrounding Psyche, we are hearing the echo of something too disruptive to disclose. We may never know with absolute certainty, but if the answer is affirmative, if 3I Atlas is indeed a probe, a machine, a deliberate traveler through the night, then history has already turned a corner. Humanity has already been visited, already observed, and our sole choice is whether we open our eyes to acknowledge it or remain comforted by the fabrication of icy debris until the stars dispatch another messenger. Part 11. Europa Clipper's imminent window. As 3I Atlas carves its brilliant trajectory towards the sun and then onward into the vastness of space, another spacecraft, far from Earth, approaches its own destiny. NASA's Europa Clipper mission, a cornerstone of astrobiological research this decade, has entered a pivotal moment that cannot be overlooked. It is no longer a distant plan, a mere aspiration to investigate the ocean hidden beneath Europa's frozen crust. Its critical operational window has arrived. In late October of the year 2025, Europa Clipper will position itself for its defining encounters, carrying with it the most sophisticated array of instruments humanity has ever directed toward a distant moon. Its stated objective is inspiring yet straightforward: to determine whether life could exist within the ice-shrouded seas of Europa. However, as we have learned repeatedly, missions are rarely confined strictly to their official mandates. The hardware itself shows little regard for initial intentions. Instruments designed to penetrate the frozen ice of a Jovian moon remain, fundamentally, instruments. They manipulate signals, capture photons, register anomalies, and in the deep, unmonitored expanses of space, intention can indeed shift. The Europa Clipper's radar system, engineered to penetrate ice undetected, possesses the capability to be repurposed for outward observation. Its advanced imaging arrays, poised to capture Europa's surface with remarkable clarity, could instead be directed toward the celestial sphere. The spacecraft's sophisticated sensors, finely calibrated for compositional analysis, might be aimed at transient celestial bodies traversing the solar system, whether entering or departing its confines. This presents a crucial juncture. The spacecraft, ostensibly a mission dedicated to astrobiology, also functions as a strategic observation post. From its vantage point within Jupiter's sphere of influence, Europa Clipper can survey vast expanses of the solar system, regions inaccessible to Earth-based telescopes. It is ideally positioned to observe an interstellar visitor, such as Oumuamua or 3I 2023A3 Tsuchinshan Atlas, should institutional directives opt to redirect its focus. This potential scenario elevates Europa Clipper from a mere exploratory probe to an entity of profound significance, carrying implications that are both larger and more disquieting. The parallel is stark, even starkly brutal. A defense radar intended to safeguard a nation against incoming missiles can also function as a surveillance tool. A meteorological satellite, initially deployed to track atmospheric phenomena, may inadvertently capture images of sensitive military installations. The infrastructure designed for observation is inherently versatile. It does not discriminate. Once established, its capabilities can extend far beyond its original mandate. Europa Clipper is no exception to this principle. Consequently, a pressing question arises: will it be employed in such a capacity? We have already witnessed instances of anomalous visitors entering our solar system, and the case of 3I 2023A3 Tsuchinshan Atlas is particularly instructive. While observations may exist, official bodies tend to close ranks. The most startling data often disappears into silence or emerges only after considerable delay. NASA's Psyche mission, for example, was expected to provide imaging of the interstellar traveler in September. However, its data transmission ceased weeks prior to a government shutdown. Was this a coincidence or a calculated maneuver? The pattern suggests more than mere budgetary exigencies. It indicates a deliberate control of the narrative. Now, as Clipper approaches its critical operational phase, are we on the verge of witnessing the next act in this unfolding drama? After all, transparency is not a guaranteed outcome. When the Cassini spacecraft neared Saturn's icy moon Enceladus, its instruments detected geysers of water erupting from the surface, a discovery that revolutionized planetary science and broadened our understanding of potentially habitable environments. Yet, the dissemination of this data was not immediate. The raw findings underwent scrutiny by committees, institutional filters, and interpretive layers before public release. The geysers became known to the public, but only after weeks of internal deliberation, presented in a carefully managed manner. This occurred for a discovery involving water vapor, a phenomenon firmly within the domain of natural science. What if the stakes had been considerably higher? What if the data had hinted not at subterranean oceans, but at a manufactured object, an artificial construct, something implying the existence of intelligence? Would such data have ever seen the light of day? Or would Cassini's revelations have been relegated to classified archives, confined to the hidden realms of government rather than the open forum of scientific discourse? This is the precedent that looms over Europa Clipper. Its designated purpose is noble, even transcendent, to explore the possibility of extraterrestrial life. However, its strategic location, its advanced instrumentation, and its precise timing intersect conspicuously with the enigmas surrounding 3I 2023A3, Tsuchinshan Atlas. Because of this confluence, the issue of transparency becomes paramount. Will Europa Clipper's instruments be permitted to record their findings without constraint? Will its data streams be shared openly, or will they be subjected to filtering, redaction, or delay? This mirrors the very institutional gatekeeping we have already observed with the Psyche mission. Space itself is without boundaries. There is no jurisdiction dictating that Europa Clipper must confine its observations solely to Europa. Its instruments will inevitably detect signals from whatever falls within their operational range. The critical decision rests not with the hardware itself, but with those who oversee the flow of information. Will they disclose what the spacecraft observes, or will they determine that certain discoveries are too destabilizing, too perilous, or too paradigm-shifting to be revealed? Consider the timing. As 3I 2023A3, Tsuchinshan Atlas, orbits the Sun, emitting anomalies that defy conventional explanation, Clipper assumes a position for its initial critical observations. Two distinct narratives converge, one of interstellar visitation and another of planetary science. Within the overlap of these narratives lies a possibility that institutions are unlikely to openly discuss, that Europa Clipper might witness something extraordinary, and that its observations could be subsumed by the same silence that has shrouded 3I 2023A3, Tsuchinshan Atlas, since its discovery. The public discourse will remain straightforward. Europa Clipper's objective is to study ice, oceans, and the potential for microbial life. Official announcements will showcase breathtaking imagery of Europa's geological features. Scientific findings will center on chemistry, geology, and the intriguing indicators of habitability. Yet, beneath this polished facade, the spacecraft represents something more. It serves as a sentinel at the solar system's periphery, equipped with instruments capable of detecting anomalies and stationed at a vantage point unmatched by any other active mission. This duality is not indicative of a conspiracy, at least not in the sensationalized sense. It is a reflection of institutional logic. An instrument is built, and it will be utilized for every purpose it can conceivably serve. a spacecraft is positioned, and it will observe more than its designated target. The ensuing silence is not necessarily malicious. It is procedural, bureaucratic, and fundamentally human. Institutions strive to protect themselves. They carefully manage narratives. Data is released in a curated and controlled fashion. However, for those who observe closely, who track the unexplained anomalies, the mysterious plumes, the vanishing transmissions, a pattern emerges. Europa Clipper stands at the precipice of this pattern. Will it perpetuate the silence, or will it shatter it? The implications extend beyond the realm of science, reaching into politics, security, and even philosophy. If Europa Clipper were to detect something unusual, a trajectory similar to that of 3I 2023A3, Tsuchinshan Atlas, or a signal inconsistent with natural phenomena, what would follow? Would the data be immediately uploaded to public servers, or would it be quarantined? Would the onboard scientists be permitted to speak freely, or would they be bound by non-disclosure agreements under the pretext of further analysis? Would the discovery become a moment of shared wonder, or would it be sequestered into institutional vaults for managed dissemination? These questions remain unanswered. What is certain is that the convergence of timing, instrumentation, and positioning makes Europa Clipper an unavoidable subject of scrutiny. It is more than just a mission to Europa. It is the next node in an expanding surveillance network, a silent witness to the cosmic traffic flowing through our solar system. As 3I 2023A3, Tsuchinshan Atlas, recedes from the Sun, Europa Clipper embarks on its historic trajectory, carrying the potential, or the peril, of becoming the next chapter in a story we are only just beginning to comprehend. The universe has no obligation to reveal its secrets in a linear fashion, one mission at a time. Discoveries often emerge unexpectedly, at the edges of observational frames, in anomalies not foreseen by research proposals or budgetary allocations. Europa Clipper may indeed uncover life beneath the ice, or it may detect something entirely different, something that compels us to reevaluate our understanding of visitors like 3I 2023A3, Tsuchinshan Atlas. The ultimate decision, as always, will not lie with the instruments, but with the silence that follows. Part 12 delves into the realm of planetary defense, or rather, planetary surveillance. The European Space Agency has unveiled ambitious plans for a mission, designated Hera, scheduled for launch in 2026. Yet, by late 2025, preparations are already intensifying, both within the laboratories developing its sophisticated instruments and within the institutional corridors where priorities are quietly being recalibrated. The official rationale is sufficiently straightforward. Hera is framed as a planetary defense mission. Its stated objective is to rendezvous with the Didymos binary asteroid system, the very same system that NASA's DART spacecraft targeted in 2022, impacting the smaller moonlet Dimorphos in the first practical demonstration of kinetic impact deflection. The purpose of Hera is to meticulously measure the consequences of this event by charting Dimorphos's altered orbit with exceptional precision. Hera will quantify the magnitude of the impulse delivered by the impact, thereby illustrating the potential efficacy of such interventions should Earth face the threat of an incoming asteroid. On the surface, the objective is clear, benevolent, and uncontroversial: to assess the aftermath of an experiment designed to safeguard our planet. Indeed, this justification is compelling. Earth exists within a hazardous cosmic environment. Throughout geological history, our planet has been subjected to bombardment by rocks and ice from space. Some of these impacts have been significant enough to alter climates, decimate ecosystems, and fundamentally reset the course of evolution. The Chicxulub impact event, occurring 66 million years ago, marked the end of the dinosaur era and created ecological opportunities that eventually paved the way for the rise of mammals and, subsequently, humanity. That singular event serves as a sobering reminder that planetary impacts are not merely rare geological curiosities, but existential threats. In this context, the billions invested in developing planetary defense strategies function as a form of cosmic insurance. By detecting threats early and deflecting them with precision, humanity secures a measure of safety against a universe that remains indifferent to our continued existence. However, as is often the case with ambitious space missions, the declared purpose represents only a fraction of the complete narrative. Upon closer examination, beyond the polished press releases, Hera embodies something more intricate and, arguably, more concerning. The spacecraft's instruments are engineered with extraordinary sensitivity. Its radar systems, optical imaging capabilities, and LiDAR sensors are calibrated to detect minute fragments, subtle shifts in trajectories, and delicate surface features on objects located millions of kilometers away. This same sensitivity, however, does not deactivate once the spacecraft departs from the Didymos system. The radar that maps an asteroid's fragmented composition can just as readily be directed elsewhere. The cameras that characterize surface boulders can just as easily monitor unusual objects traversing interplanetary space. In this regard, Hera exemplifies the dual-use principle that has consistently characterized technological advancement. Every defensive system inherently possesses surveillance capabilities. A radar designed to detect incoming missiles also tracks civilian air traffic. A weather satellite launched to study storms inevitably captures imagery of military installations, power generation facilities, and troop movements. A telescope intended for planetary defense studies simultaneously functions as an instrument for observing anything entering the inner solar system, whether mundane or anomalous. This dual-use character is not an unintended consequence. It is an intrinsic structural feature of technology itself. Once the capacity to monitor for threats is established, the ability to monitor for everything else is automatically acquired. The unsettling parallel lies with missile defense systems. When nations developed early warning radars, the justification was invariably rooted in self-preservation. If an incoming strike is detected, a response can be mounted before annihilation occurs. Yet, once these radar installations and satellites became operational, their role inevitably expanded into broader surveillance networks, monitoring not only nuclear missiles, but also atmospheric testing, rocket launches, and even orbital debris. This infrastructure evolved incrementally, often without commensurate public discourse, to keep pace with the evolving reality. Hera is poised to follow a similar trajectory. For public consumption, it is presented as a planetary defense initiative, but its actual operational function extends into a more clandestine domain. It transforms, whether explicitly acknowledged or not, into a surveillance platform for interstellar anomalies, becoming a sentinel against visitors akin to 3I 2023A3, Tsuchinshan Atlas. This is where the context sharpens into focus. In recent years, since the appearance of Oumuamua and subsequently 3I 2023A3, Tsuchinshan Atlas, the scientific community has been compelled to grapple with celestial objects that defy conventional classification as either asteroids or comets. They exhibit peculiar accelerations, display unusual spectroscopic signatures, and generate anomalous jets from unexpected regions. Most disturbingly, the institutions tasked with their observation have demonstrated patterns of selective silence, delayed data releases, or conspicuous interruptions in transmissions precisely when the public might anticipate clarity. During 3I 2023-A3 Tsuchinshan Atlas's flyby of Mars, multiple orbiters were ideally positioned to capture detailed imagery. However, only carefully curated images, devoid of anomalies, were eventually released. When NASA's Psyche probe was positioned to potentially capture images in September 2025, its data feed abruptly went silent. Only weeks later, a ground-based telescope revealed evidence of a propulsion-like jet emanating from the object's front, perhaps the most perplexing observation yet. This institutional silence establishes a precedent. If the agencies already responsible for planetary science selectively control information regarding anomalies, what grounds do we have to expect Hera to behave differently? Its data, much like Psyche's, will likely be channeled through official conduits, filtered by institutional protocols. Its instruments, while capable of monitoring anomalies, will be reported on solely within the framework of asteroid deflection. Should something unexpected be detected, such as a trajectory inconsistent with natural forces or a material composition that is anomalous, the most probable outcome would not be immediate public disclosure, but rather a classified review. The template for this scenario has already been established by the handling of Oumuamua and 3I 2023-A3 Tsuchinshan Atlas. The ethical and political question is whether this dual-use nature should be openly acknowledged. When taxpayers fund a mission like Hera, their understanding is that it is a planetary defense endeavor. Yet, what if its instruments are also covertly tasked with monitoring for anomalies? Should the public not be apprised that their defense mission also functions as a surveillance system for detecting interstellar visitors? Should there not be open deliberation regarding protocols for instances where Hera detects something unequivocally artificial? The refusal to articulate these questions does not negate their existence. It merely relegates them to the background, allowing decisions to be made behind closed doors. This silence is not necessarily rooted in malice. Institutions evolve according to predictable patterns. Once the capability for monitoring exists, it will be utilized. Once data streams are established, they will be scrutinized. And once anomalies are identified, protocols will be devised for their management. What commences as planetary defense inevitably expands into planetary monitoring, then progresses to anomaly detection, and ultimately culminates in information control. This sequence is not indicative of a conspiracy, but rather a form of bureaucratic inertia. Nevertheless, the outcome is similar. The public narrative remains focused on planetary defense, while the actual operational capability encompasses something far more extensive. In late 2025, as 3I 2023-A3 Tsuchinshan Atlas recedes into the outer solar system following its dramatic perihelion passage, the timing of Hera's intensified preparations feels almost symbolic. One interstellar visitor departs, another spacecraft gears up for launch, and the infrastructure for a new phase of space science begins to materialize. We are transitioning from an era of passive astronomy to an era of active interception and surveillance. We are no longer content to await the chance appearance of anomalies in telescopic observations. Instead, we are constructing spacecraft to intercept them, to measure them, and to guard against them. In doing so, we are blurring the lines between science and security, between exploration and control. The risk lies in the inability of public transparency to keep pace with institutional adaptation. The same agencies that opted for silence during the Psyche data cutoff and the Mars flyby will likely extend the same reticence to Hera's data when the time comes. The public will receive polished announcements detailing orbital deflection efficiency, information about rubble pile asteroids, and assessments of surface composition. And perhaps, subtly obscured, there will be anomalies, signatures, and trajectories that deviate from the norm. These anomalies will not feature in press releases. Instead, they will be routed into classified channels, subjected to study by committees whose deliberations remain entirely outside the public sphere. This represents the emerging pattern of 21st century space science. It is not a conspiracy orchestrated by individuals, but a structural evolution of institutions. As technologies become more potent, their applications broaden. As anomalies multiply, protocols of concealment deepen. As planetary defense morphs into planetary surveillance, we enter a new era where algorithmic gatekeeping dictates the information available to the public regarding the universe. Hera, in this context, transcends its designation as a mere mission. It symbolizes this transition. On the surface, it measures the deflection of an asteroid. Beneath the surface, it constructs the infrastructure for monitoring interstellar anomalies. And behind closed doors, it establishes protocols for discoveries that could fundamentally challenge our understanding of what traverses our cosmic neighborhood. The silence that followed, 3I 2023A3, Tsuchinshan Atlas, will not dissipate with Hera's mission. It will become institutionalized. As 2025 draws to a close with the spacecraft nearing completion, the pertinent question we must pose is not whether Hera will fulfill its stated mission. Rather, it is whether we, the public, will ever be granted access to the complete scope of its discoveries. Part 13 examines the role of artificial intelligence, AI, in space science, functioning as a hidden arbiter. Throughout 2025, the astronomical community has increasingly incorporated artificial intelligence, AI, and machine learning, ML systems to process the immense volume of data emanating from space telescopes and interplanetary spacecraft. This is not merely a matter of efficiency, it is a necessity for survival. Modern observatories generate more data in a single day than astronomers could manually analyze over many years. The James Webb Space Telescope, JWST, alone produces terabytes of raw imagery and spectroscopic data every 24 hours. When combined with contributions from Hubble, Chandra, TESS, Gaia, ground-based surveys like Vera C. Rubin Observatory, and planetary spacecraft such as Psyche, Europa Clipper, and the Mars orbiters, the data flow becomes unmanageable. Consequently, astronomers have embraced automation. AI now serves as the initial point of contact for the majority of cosmic data, acting as a filter, organizer, and triage specialist before any human researcher begins their analysis. At first glance, this appears logical. Without automated classification, data archives would inundate researchers with extraneous information. However, as with any filtering process, the danger lies not in what passes through, but in what is excluded. This represents a critical threshold that has received virtually no public attention. When AI assumes responsibility for the initial categorization of data, it gains immense power over what humans ultimately perceive. Every system is designed with inherent assumptions. Algorithms are trained on examples of normal and anticipated signals. When an observation aligns with these expectations, it seamlessly enters the public archive. When it deviates, the system does not discard it. Rather, it performs a more subtle action. It raises a flag. If the anomaly resembles instrument noise, the system may classify it as an error. If it indicates a deviation from a known pattern, it is routed to a review pipeline. If it is too extreme, it may be placed in an indefinite pending verification status. This means that a telescope can capture extraordinary physical phenomena, but whether the world ultimately witnesses it depends on whether the anomaly successfully navigates both algorithmic and human gatekeepers. To be fair, anomaly detection is not inherently sinister. In fact, it is indispensable. In medical imaging, AI highlights unusual growths in an MRI that a radiologist might overlook. In cybersecurity, anomaly detection flags unusual network activity before a breach escalates. In astronomy, it prevents corrupted pixels, cosmic rays, and telemetry glitches from being mistakenly identified as exoplanets or supernovae. Without this capability, scientific research would be overwhelmed by false positives. Yet, a paradox emerges. What happens when the anomaly is not mere noise, but genuine novelty? What transpires when the very revelation we seek appears to an algorithm trained on past data as mere error? Now, let's apply this framework to 3I Atlas, the third documented celestial body traversing our solar system, and arguably the most enigmatic to date. Should NASA's Psyche probe or YS's orbital craft have documented observations of a solar jet diverging from typical sublimation processes, exhibiting a nickel-rich composition devoid of iron, or displaying non-gravitational accelerations in two opposing directions unexplainable by outgassing, then each of these peculiar characteristics would have, from the AI's perspective, triggered anomaly alerts. These data points do not align with any established training datasets. Consequently, the system would automatically categorize them as suspicious, diverting them from the primary data stream into a controlled review process. It's important to note that this scenario requires no clandestine plotting. It's simply the system functioning as designed. However, once flagged, human discretion within the institution comes into play. Decision-makers must then determine whether to immediately disseminate the findings, detain them for extensive analysis, or perhaps subtly postpone or even conceal them. The hiatus observed within Psyche's data archives, specifically between September 1st and September 5th, the very period it should have captured images of 3I Atlas, now appears less as a technical malfunction and more as the telltale sign of a data pathway intentionally rerouted into quarantine. The unifying theme is that anomalies enter a state of limbo, neither outright rejected nor definitively confirmed, but rather suspended in a zone where those in authority possess boundless discretion. Now, envision applying that same structural logic to the field of astrophysics, where an anomaly might signify not a biological abnormality or a cyber intrusion, but rather the initial indication of non-human technological presence in the vast expanse of interstellar space. A more profound peril exists. The datasets utilized to calibrate these artificial intelligence filters are constructed upon fundamental assumptions of normalcy. Spectrums of comets are modeled based on ice, silicates, and organic compounds. Orbital mechanics are predicated on Newtonian and post-Newtonian principles. Stellar jets are explained through sublimation physics. However, if nature or advanced engineering presents something that falls outside these preconceived parameters, the algorithm struggles to process it. It only recognizes that this deviates from the expected. Therefore, the more sophisticated our anomaly detection systems become, the greater the risk that they transform into engines for suppressing novelty. What is intercepted might not be mere noise, but rather the very vanguard of discovery. Overlaying this, we must consider institutional psychology. Agencies like NASA operate under immense political scrutiny. Their reputations are contingent upon avoiding public embarrassment. Data disclosures that appear too peculiar risk eliciting ridicule, misinterpretation, or sensationalized headlines. This cultivates a system wherein the data carrying the most significant implications, the very anomalies that could potentially redefine our understanding of physics, are the least likely to be brought to light. This leads us back to Psyche. Officially, Psyche's archive of raw imagery reveals no files between September 1st and September 5th. The data feed resumes on September 8th, with no information to account for this blackout. If an algorithm had flagged observations of 3I Atlas during that interval, the data might have been directed into internal review pipelines. From there, human committees could have elected to withhold it, perhaps out of prudence, apprehension of error, or concern over its implications. These reasons remain unknown. What is certain is that the temporal gap is a reality. The missing days precisely coincide with the period during which Psyche was expected to capture the most revealing close-up images of 3I Atlas, and the silence that has followed has been absolute. This transcends the scope of the Psyche mission. What we are observing is the initial public manifestation of a more fundamental systemic alteration. The practice of astronomy in the year 2025 operates vastly differently from its counterpart in 2005. In those earlier times, data processing pipelines were considerably simpler. Telescopes transmitted raw files directly, and researchers meticulously examined them, anomalies included. Today, artificial intelligence filters are the initial arbiters, determining what appears normal, what warrants flagging, and what should be discarded. The filtering mechanisms are more refined, the gatekeeping more automated, and the transparency significantly reduced. The very infrastructure designed for discovery has, without question, evolved into an infrastructure of control. Ironically, this transformation was necessitated by genuine exigency. The sheer volume of data is an undeniable reality. Without filters, the system would inevitably collapse under its own overwhelming weight. However, in resolving one challenge, a new one has emerged. A system where the threshold for what constitutes novelty is set lower than reality itself. When an interstellar object like 3I Atlas exhibits unusual behavior, accelerating contrary to predictions, emitting nickel-rich jets, and defying gravitational modeling, the system does not register it as a cause for celebration. Instead, it quarantines the data. Consequently, the very tools intended to safeguard us from erroneous conclusions may be inadvertently ensuring that we overlook the most critical truths. This discussion is not confined to a single spacecraft, a solitary comet, or a particular missing batch of images. It concerns the very future of discovery. If we permit anomaly filters and institutional discretion to dictate the parameters of what scientific information is accessible, then our comprehension of the cosmos will be confined to the limitations of our existing expectations. We will only uncover that which we already possess the capacity to categorize. The historical trajectory of scientific advancement demonstrates a contrasting pattern. Genuine breakthroughs invariably emerge as anomalies. Radioactivity was initially perceived as an error until it ushered in a scientific revolution. Quasars were dismissed as radio noise until they revealed the existence of black holes. Dark matter originated as a disparity in the rotational curves of galaxies. Every frontier in science began as an anomaly that someone chose to investigate with seriousness. The narrative of 3I Atlas compels us to question: are we still prepared to confront anomalies, or have we constructed a system where algorithms and committees discreetly remove them from our view? If the latter is true, then the true scandal lies not in the absence of Psyche's images, but in the fact that we have engineered a paradigm where anomalies are systematically eliminated. Science flourishes when its most unexpected surprises are allowed to see the light of day. Without this openness, we risk a future where our telescopes observe everything, yet humanity learns nothing. Part 14. The Unfolding of New Physics. Within the scientific literature of 2025, the initial indications of genuinely novel physics have begun to surface. These are not the routine, incremental adjustments, the minor modifications to orbital mechanics, or the incorporation of new coefficients into established equations. What is now emerging hints at something more profound, originating from the cutting edge where interstellar objects interact with our established models of solar radiation and gravity. The nexus of this scientific tension is 3I Atlas, an interstellar visitor whose behavior seems intent on defying conventional cometary physics. From the earliest high-resolution datasets, institutions monitoring 3I Atlas identified characteristics that simply did not conform to expectations. Estimates of its mass suggest an anomalous density relative to its apparent size. If one considers its observed luminosity, surface area, and coma formation at face value, the predicted mass would be consistent with volatile ices mixed with rocky silicates, essentially another dirty snowball. However, the calculations persistently failed to align. Instead, 3I Atlas appears significantly more massive than its dimensions would suggest, as if it were composed of metallic alloys or meticulously engineered composite materials rather than porous ice. This discrepancy alone would be sufficient to occupy theorists for a considerable period. Yet, this is merely the outset. The true point of contention lies in the object's acceleration patterns. Conventional comets experience increased velocity or shifts in trajectory due to a well-understood phenomenon known as non-gravitational acceleration. As a comet approaches the Sun, volatile substances within its nucleus vaporize. The expulsion of these gases creates jets, generating a gentle but sustained propulsion, akin to numerous miniature thrusters firing intermittently. Astronomers have long since incorporated this effect into their orbital models. It is so routine that software such as JPL's Horizons can predict it without fanfare. Outgassing is the reason cometary paths deviate from purely gravitational trajectories. It is an expected, documented, and rarely controversial occurrence. However, 3I Atlas is not adhering to these established norms. The magnitude, and more critically, the directional vector of 3I Atlas's acceleration do not align with any sublimation model based on thermal processes. Rather than a chaotic, averaged set of microjets, we observe forces that are too powerful, too precise, and too consistently oriented. Imagine observing a campfire. Sparks and smoke disperse randomly. Now picture those sparks all moving in perfect formation, as if directed by an unseen force. That is the degree of peculiarity we are confronting. If one were to diagram the acceleration vectors, components would emerge that appear orchestrated rather than random. The force is not only greater than theoretical models predict, but it frequently points in directions that simple outgassing cannot account for. Initially, mainstream theorists considered electrostatic forces. The solar wind, a stream of charged particles that permeates all objects within the inner solar system, can interact with dust clouds and generate forces beyond gas pressure. This is a valid physical phenomenon, as comets often possess charged environments. However, calculations indicate that the magnitude required in this instance would far exceed what solar wind typically produces, almost as if asserting that a household fan could propel a truck down the street. Another hypothesis is radiation pressure. Light itself possesses momentum, and over extended periods, it can exert force on small objects, particularly those that are thin and reflective, akin to a solar sail. Comets, however, are typically irregular, tumbling bodies that absorb light rather than reflecting it like a mirror designed to harness photons. While the push from sunlight is a real factor, it is insufficient to explain the observed accelerations unless 3I Atlas possesses surfaces or coatings unlike anything found in nature. In essence, natural mechanisms are stretched to their limits, but the fabric of understanding tears before it can encompass these anomalies. This leaves the explanation that most scientists are reluctant to articulate: active propulsion. What if 3I Atlas is not a passive celestial body, but rather a craft or probe navigating the solar system with deliberate intent? The solar jet observed in August imagery would, under this interpretation, represent not sublimation, but rather thrust. Its anomalous composition, nickel, cyanide complexes, refractory materials, suddenly appears less like random chemical processes and more like engineered design optimized for durability in high radiation environments. The analogy is straightforward. If you witnessed a vehicle ascending a hill without its wheels touching the ground, you would logically infer some form of hidden propulsion. Similarly, if a cosmic object accelerates in ways that cannot be explained by outgassing, one is compelled to consider whether an unobserved force is responsible. Now, none of this confirms the extraterrestrial probe hypothesis. Far from it. The culture of astronomy thrives on skepticism, and rightly so. Extraordinary assertions demand extraordinary evidence, and proposing that an interstellar object is an engineered craft would constitute one of the most extraordinary claims in scientific history. Consequently, in scientific journals and conferences, the prevailing tone remains one of caution. Authors frame their findings in passive voice, temper their conclusions, or emphasize uncertainties in their models. Publications such as Sky at Night magazine acknowledge the anomalies, but prioritize the search for natural explanations. This conservatism is understandable. However, herein lies the peril. Caution can devolve into suppression when it blinds us to phenomena that genuinely exceed our current frameworks. Skepticism transforms into dogma when it refuses to entertain the possibility that the data accurately reflects what it appears to be. This is precisely why the silence surrounding NASA's Psyche probe has acquired such an unsettling aura. The spacecraft was publicly scheduled to image 3I Atlas around September 3rd to 4th. Yet, within Psyche's raw data archives, there is a distinct gap. Between September 1st and 5th, no images are recorded. The data stream only resumes on September 8th, and no official explanation has been provided to bridge this interval. This is distinct from the government shutdown that commenced on October 1st. The missing data falls outside that temporal period. This raises the immediate question: was this an inadvertent lapse, a system malfunction, or a deliberate omission? If Psyche captured something profoundly anomalous during those missing days, withholding such information would represent not merely bureaucratic inertia, but an act of information control. Imagine if the initial images of microbial life on Mars were quietly deleted and never publicly acknowledged. Such an act would fundamentally alter the relationship between scientific inquiry and institutional power. The Psyche data blackout does not exist in isolation. The European Space Agency has also been entangled in its own data-related controversies. The ExoMar Trace Gas Orbiter initially scheduled data releases that, due to a glitch, were marked as embargoed until the year 2099. Was this an embarrassing error or a subconscious revelation? The response was to impose a comprehensive delay, pushing all releases to April 3rd, 2026. Meanwhile, a recently released image from the ESA, captured in August, depicts a sunward jet emanating from 3 Atlas that aligns perfectly with the narrative of anomalous acceleration. This delayed disclosure feels less like transparency and more like a controlled, gradual release of information. Furthermore, there are still high-resolution datasets pending from the HiRISE instrument on Mars, along with upcoming flyby opportunities in late October involving the Hayabusa spacecraft and the Europa Clipper. Each presents another potential opportunity to observe 3I Atlas at close range. Each becomes another test case for whether data will flow freely or disappear into silence. If the anomalies associated with 3I Atlas are indeed genuine, if the object is accelerating in ways that necessitate new physics or reveal concealed propulsion systems, then what is being suppressed is not merely scientific curiosity, but potentially the key to an entirely new field of knowledge. Consider historical precedents. Radioactivity was once a peculiar anomaly, observed as rocks emitting a faint glow in the dark. Superconductivity was a laboratory oddity, unexplained for decades. Each phenomenon defied expectations until theoretical frameworks evolved to accommodate them, and each ultimately revolutionized entire industries. Now, contemplate the possibility of propulsion without conventional fuel, spacecraft navigating by light, or materials engineered to withstand the harsh conditions near stellar environments. If 3I Atlas embodies any of these possibilities, then the missing Psyche data represents not just a bureaucratic oversight, but the suppression of potentially revolutionary science. The very institutions designed to expand human knowledge risk becoming its guardians. By controlling data release schedules, characterizing anomalies as mere glitches, and maintaining official silence, they transform from centers of research into fortresses of information. This is not a matter of conspiracy theory. It is a consequence of structural sociology. Large organizations instinctively seek to protect themselves from reputational damage. The more extraordinary the data, the higher the perceived risk, and the stronger the impulse to conceal it. However, in doing so, they stifle the very engine that drives scientific progress. Science thrives only when anomalies are confronted directly. The blackouts, delays, and embargoes suggest a shift away from direct confrontation towards concealment. Taken collectively, these facts paint a disquieting picture. If 3I Atlas truly represents novel physics or even engineered propulsion, then we are not merely failing to confront it. We are actively avoiding it. This moment feels akin to standing at the edge of a dark forest, hearing something immense moving amongst the trees, and choosing to cover our ears rather than step forward with a light. Caution is a natural response. Fear is understandable. However, history demonstrates that progress is achieved by those willing to face the anomalies that others dismiss. If the institutional silence persists, then the true scandal will not be whatever 3I Atlas ultimately proves to be. The scandal will be that we turned away when the universe offered us the opportunity to fundamentally rewrite the physics of reality itself. Part 15. Extending beyond Atlas, recognizing the pattern of silence. To fully grasp the significance of 3I Atlas, we must broaden our perspective and acknowledge that this solitary object represents not an isolated anomaly in data management, but rather a thread woven into a much larger tapestry of concealed scientific findings and withheld information across numerous disciplines. This pattern has become discernible once one knows what to look for, manifesting across diverse research and technological domains in ways that suggest something more profound than mere random institutional delays or coincidental bureaucratic confusion. Consider the community engaged in fusion energy research. Experiments conducted at facilities like CERN and various privately funded ventures have yielded groundbreaking results that should have precipitated celebratory announcements and accelerated publication cycles. Yet, the release of detailed data has consistently lagged behind these initial announcements. Findings are presented in summary form, while raw data remains under restricted access pending further review and validation protocols. The pattern suggests that elements within these results warrant special handling before public dissemination. However, the specific nature of what requires such caution has been communicated vaguely or withheld entirely. The fusion community occupies a peculiar institutional space where national security considerations intersect with commercial competition, creating plausible rationales for secrecy, even when the discoveries are ostensibly related to civilian science. The Chinese Fast Radio Burst Telescope, one of the most powerful instruments globally, has detected ultra-fast radio bursts and accumulated data on transient phenomena that would ordinarily be shared with the international astronomical community for collaborative analysis. Nevertheless, significant portions of the data collected by FAST remain inaccessible to researchers outside of China. The justification provided emphasizes scientific priorities and the ambition to publish findings first in domestic journals. However, the overarching consequence is the same. Vital astronomical data is sequestered, unavailable for the kind of collaborative verification and analysis that accelerates discovery. This pattern transcends geopolitical boundaries. It is evident in both Western and non-Western scientific institutions, suggesting a systemic shift in how we manage cutting-edge data, moving towards greater restriction. Defense aerospace agencies have similarly classified vast quantities of information concerning spaceplanes, advanced launch systems, and orbital platforms. Organizations such as DARPA maintain opaque protocols surrounding the development and deployment of space-based assets that could potentially observe Earth or the wider cosmos. This secrecy is legitimized through valid national security frameworks. Yet, its effect is to remove from public knowledge extensive sectors of space technology and observational capability. We are unaware of what such systems might discover. We do not know how they might observe 3I Atlas or similar phenomena. We simply understand that this capability exists, is being developed and deployed, and operates entirely outside public oversight. When these examples, from fusion research, radio astronomy, and military aerospace, are considered alongside the data restrictions surrounding 3I Atlas, a coherent pattern emerges that extends beyond any single institution or mission. We appear to be witnessing the emergence of a new standard in scientific data management, where anomalies, unexpected discoveries, and phenomena that deviate from established models are subjected to systematic gatekeeping treatment. The mechanisms employed vary. Sometimes, data is simply retained in restricted archives pending review. Other times, it is processed through algorithmic filters that delay or suppress anomalous readings. In some instances, it is sequestered under national security protocols. Occasionally, it is withheld through international data embargoes designed to coordinate release timing. The specific methods employed are less significant than the convergent outcome. Access to anomalous data becomes restricted, and this restriction operates largely without public discourse or consent. The societal implications warrant direct articulation. Within democratic societies, we have historically operated under the presumption that the public possesses the right to access scientific data and to participate in discussions about the implications of discoveries for our understanding of reality. We have established institutions founded on the principle of transparency. We have created legal frameworks mandating open access to research funded by public monies. We have embraced the ideal that knowledge belongs to humanity, rather than to institutional gatekeepers. However, the emerging pattern of silence in 2025 suggests that this commitment may be eroding, supplanted by a more restrictive model wherein anomalies are treated as potential threats to institutional authority rather than as opportunities for genuine discovery. Who holds the authority to dictate what the general populace and the wider scientific community are permitted to access? What transpires when phenomena appear that fall outside the purview of our established models? These inquiries become progressively more pressing as the infrastructure for identifying and monitoring extraordinary events expands. In the ensuing weeks, Europa Clipper will focus its observations on Jupiter. HiRISE is slated for its deployment in the year 2026. A multitude of other spacecraft and observatories will persevere with their work, accumulating information that will be processed through automated systems and subjected to review procedures by various organizations. Should the current trend of restricted information persist without alteration, then the most profound revelations will be those that remain unseen by us, the visual records we are denied the opportunity to scrutinize, and the information we are never granted the chance to interpret. Let us now revisit the outset, the absent data from 3 Atlas and Psyche. If the absence of communication is more pronounced than the available information, then the paramount narrative conveyed by this entire sequence of events is not what we witnessed, but rather what we were deliberately prevented from observing. The most significant revelation might well be that which we have yet to be permitted to perceive. As we anticipate the next scheduled release of data from HiRISE in April of 2026, direct your focus not towards the information that is presented, but towards the information that is conspicuously absent. Be vigilant for these omissions. Take note of any postponements. Observe the instances where organizations attribute delays to procedural hurdles rather than clear scientific justifications. The pervasive lack of communication, spanning fusion research, radio astronomy, aerospace initiatives, and presently, observational commentary, speaks volumes about systemic shifts occurring subtly, without fanfare, and devoid of public discourse. It illustrates how systems designed to enhance human comprehension can morph into mechanisms that impede understanding when potential insights threaten established hierarchies of power and influence. Ultimately, the enigma surrounding 3 Atlas and Psyche's missing observational period may not pertain to the celestial body itself, but rather to ourselves, to our readiness to embrace certain truths and our inclination to actively suppress others. The most impactful discovery might not reside within the data we are shown, but in confronting the fundamental question of why we are precluded from accessing it. This inquiry carries ramifications extending far beyond the realm of astronomy, far beyond the trajectory of this singular object nearing the sun. It has implications for the very fabric of the civilization we are evolving into, concerning our confidence in our institutions to uphold truthfulness, and conversely, whether these institutions place their trust in us to handle knowledge that they deem too destabilizing to control. These are the questions that will resonate long after 3I Atlas has traversed its closest approach to the sun and vanished into the distant void, leaving us to ponder what we may have overlooked and what we deliberately chose to disregard.